We are coming to solve frequency distribution table, and on the table we are supposed to find the standard deviation, the variance, the mean, and the modal class. For group frequency distribution table, we don't have x. So what we have to do is that we have to create a space for x. So by creating the space for x, we are called a midpoint. So this is by adding the two limits and dividing it by 2. We have to create a space for the deviations too. That's x minus the mean all squared, and also create a space for frequency multiplying the deviation. So now that's what we are coming to do. So midpoint. So what we do is that we add
x,
which is the x. We add 100 to 109, then you divide it by 2.
104.5.
You get 104.5. Then 110 plus 119, all divided by 2.
114.5.
Then we have 120 plus 129, all divided by 2.
124.5.
124.5. Then we have 130 plus 139, all divided by 2.
134.5.
134.5. Then we have 140 plus 149, all divided by 2. 144.5. Then we have 150 plus 159, all divided by 2. We get
154.5.
And one thing is that in the midpoint, we don't have the total. We don't have total value. Okay. So now we are going to create a space for the deviation. So the deviation is x minus the mean all squared.
Good.
So therefore, we have to find the mean.
Good.
So in finding the mean is sigma, so mean we go to sigma f.
I was thinking you create another column also for fx, f of x.
Okay. Yeah, okay. So we've gotten the midpoint. We will create a space for f of x, which is the frequency multiplying the midpoint. So f of x. Then we bring the deviation, which is x minus the mean squared. Then f multiplying the mean, the deviation, sorry.
Good. Excellent.
So we are now told, as it implies, fx, meaning that we are multiplying the frequency by the midpoint.
Good.
So we have 4 multiplying 104.5,
418.
which is 418. Then 8 multiplying 114.5,
916.
giving us 916. Then multiplying 12 by 124.5,
1494.
1494. Then multiplying 11 by 134.5,
1479.5.
147.5.
9.5.
Then we multiply 9 by 144.5.
1300.5.
Then we multiply 6 by 154.5.
927.
9.
27.
Then we add
the sum.
We sum the
Sum of f of x.
sum of f of x. So sum of f of x will be
And the sum of f is equal to 50. Summation of f.
So we are summing f of x, then we know that the sum of f is 50. So the summation of f of x, 6, 5, 35. So 6,535. So we can conclude, we can now calculate for our mean. So we know that mean equals sum of f of x over n,
Which is the same as sum of f.
over n,
Or some of
or sum
it.
of f. So therefore mean will be equal to 6,535 all over 50.
130.7.
So mean will be equal to meaning
130.7.
So therefore we have our mean to 130.7. So we are going to use this mean in calculating for our deviation. So what we are going to do is that we take each frequency, we subtract the mean from it, then we square it. So 4 minus 130.7 all square. Then here will be 8 minus 130.7 all square. We have 12 minus 130.7 all square. Sorry.
Yes, go ahead. Go ahead.
So we've made a mistake. So we are taking mean from the x, so it should be this one.
All right.
Yeah. What is it?
Yeah.
Because most values is very too much. You get serious values. Okay. So for us to calculate the deviation, you take each x, which is the midpoint. So the midpoint is 104.5, subtracting it from 130.7, then we square it. Then we have 114.5 minus 130.7 all square. We have 124 minus 124.5 minus 130.7 all square. We have 134.5 minus 130.7 all square. We have 144.5 minus 130.7 all square. Then we have 154 minus 130.7 all square. 154.5 minus 130.7 all square.
Good. Excellent.
So please divide this.
8,
6,
86.44.
4, 4.
And you multiply by 4 to get the f of the deviation.
Yeah, so here it gets multiplied by 4, then you get the f, meaning that this f, which is this, multiplying the deviation. So you multiply this 4 by the deviation we had there, then to give you f multiplying the deviation. So multiply by 4.
2745.
27
45.76.
76. Then the next one, 114.5 minus 130.7 squared.
262.44.
262.44 multiplying 8.
2099.
2099.52.
0.52.
Then we have the next one. So 38.44
Yes.
multiplying 12.
461.28.
461.28. Then you do 134.5 minus 130.7 all squared.
14.4.
14.4 multiplying 11.
11.
158.84.
84. Thank you for that. Then 144.5. Taking 130.7 from it.
190.44.
190.44. Okay. So multiplying it by 9.
1713.96.
1713.96. Then you take 130.7 from 154.5 all square.
566.44.
566.44 multiplied by 6.
3398.64.
64. So
We have to do sum of
we
F
have to
of
sum of F into all squared. So all.
Yes, sir. One zero five seven eight.
10578 as total. So now we have f of summation of f of x, then we have the summation of f multiplying the deviation.
Yes, so the question you ask yourself is it for sample data or is it for population data?
So wave sample.
So let's assume it's a sample data. So now state the formula
Okay. This
for
one's
the
clean.
for the variance. Don't clean. You can write it down.
Okay. So now, when after doing this, you ask yourself whether this calculation is it for sample data, this frequency, is it for sample data or for population data? So for sample data, you know that the variance will be equal to the summation of f multiplying the deviation
Good.
all divided by, for sample data, it will be the frequency, summation of the frequency minus 1.
Okay.
Then for population data, it will be variance because summation of f multiplying the deviation all divided by the frequency, the summation of the frequency.
Excellent. So now let's use the sample data formula.
Okay. So now we are coming to use the sample data formula. So now we put it on our hood. So we just substitute the values into the formula. So we know that the summation of the frequency, so variance will be the summation of the frequency multiplying the deviation.
That's the
Is
10578.
10578. Then the summation of the frequency is the 50. So it will be 50 minus 1.
Good.
Therefore, to 10578 all over 49.
215.88.
So therefore, our variance for our sample data is 215.88.
Standard deviation.
So now, when we want to calculate for standard deviation, it's just the square root of the variance. So standard deviation equals the square root of variance. So we get SD equals the square root of 215.88. Therefore, SD will be equal to
14.69.
so then for our SDO or standard deviation, it was 14.69.
Excellent.